Hello and welcome to the online lecture series on the course of Object-Oriented Programming. In this video, we will cover the remaining topics of Chapter 5, Functions. We will start from page number 176 and we will go on till page number 193. In this video, we will see how we can take output from a function. Like in the last video, we have seen the arguments to a function, meaning inputs to a function. But in this video we will see how we can take output from a function. Then we will talk about the return statement that generally we will see in our main program body. At end of every program we give return 0. We will try to understand what exactly it means. Then we talk about how we can eliminate unnecessary variables from our main program to minimize the size and to occupy less amount of memory. And then we'll see how we can take the structure as an output from a function. We have seen input as a structure to a function, but in this video we will see how we can take the structure as an output from a function. Then we'll talk about two major crucial topics in functions. One is reference arguments and second is overloaded functions. So we'll cover these contents in this video. Now let's begin with the very first topic, which is returning values from the functions. So whenever we give argument to a function, it is known as input to a function, and when the function performs that specific task, it usually gives us a value, and that value is called return from a function, and that is called output of a function. Right? So output of a function simply means what function returned to us. So we give input to a function, that is argument to a function, and then function performs some kind of task on that input and then give us an output, and that output is called returning from a function. Right? So in simple words we can say that we ask a question from a function and function give us an answer. Right? So the answer to a question is returning from a function. Right? So whenever function perform any kind of task on any kind of input, it gives us an output, and that output is called as returning values from a function. Right? So let me show you a program which is basically takes input from a user and it converts in certain physical quantity. Right? So this program basically takes value of pounds from a user and then convert that pounds into a kilogram. And to do this task, it calls for a function, and the function performs this specific job. Right? So generally in mobile phones we have these kind of applications which perform unit conversions and which performs pounds to kilograms and meters to centimeters and inches to feet. So all these applications are basically designed using these kind of functions. Right? So the idea of this program is to take values in pounds from the user and then convert those pounds into the kilogram. And to do this task, it takes a value from the user and it calls a function, and then function performs that specific job and give us the output, and that output is called the returning values from a function. Right? Let me explain to you this program first. So on the top we have a library here, then using namespace std. It's a function declaration. So this statement is nothing but function declaration. So the argument to the function is float in the nature, but at the moment we do not know what exactly is the input, but the nature of the input is very clear, and which is float. And then the function name is pounds to kilogram. So this is the function name, and the function name, as I mentioned to you, should be very reflective. By reflective I mean when you see the function, it clearly shows you what kind of task it will perform, and the output value is float in nature. So in the last video we have seen that the output was void. Void means null, nothing. So it's very possible that function may not give you any kind of output. That means function will perform some kind of job, but there will be no number on the output side. But in this program the function is returning us a value, and that value is float in the nature. Right? And then the main program starts from here. Now we have two variables. One variable is pounds, which we will take from the user, and other variable is output, which is kilograms. Right? Now these both values are basically float in nature. So first statement is we will ask the user to enter the value in pounds, right? So the user will enter value in pounds, and that value will be saved in pounds variable here, and then this variable will be acting like in a input to the function, right? So we'll call the function here to perform this task, and the task is we need to convert this pound into the kilogram, and for this reason we have called this function and we have given this as an argument, and this value which is input from the user is basically argument to the function. And finally this is the statement, output statement, that your weight in kilogram is this much, so we get the kilograms on output side. Now this is the function definition. Now in function definition you see here there is an argument here, input to the function, which is pounds, which is coming from right here, and this pounds is definitely a float in nature, so float value will be stored here in the variable pound. So this pound variable will be storing the value which is coming from the user. So the main program body will give arguments to the function, and function will perform some kind of job and will return a value, and that value will be in float in nature. Now the formula is, so output of course is in kilograms, so float kilograms is equal to this constant number multiplied by pounds, and then when this task is being performed we'll get an output which is kilogram. So therefore the function will return some kind of value, and that is called as return statement. So whenever function returns you any kind of response, any kind of value, any kind of number, then you have to mention it, return this thing, return that thing. So you have to clearly mention this thing. Now you might see that these variables in the function definition are different from the main function body, and which is very okay, but the nature need to be same. Like kilograms is in float nature, and pounds is also float in nature. So if you see pounds is in float in nature, and kilogram, which is the output from this function definition, is float in nature. So the output nature or input nature need to be very similar as we have mentioned in the main program body, and whatever the value it will return will be coming in return statement. So this program, this function can only return one value at a one time. It cannot return more than one value, right? If it is returning more than one value, then we need to use different techniques, right? But in the simplified way, one function can perform only one specific task. It cannot perform more than one task, right? However, a function can return more than one values, but then we will not use return statement. Return statement is only used when a function returns only one value. If a function is returning more than one value, then you need to go with different techniques, which we'll cover in this video, right? I hope this is very clear to you, right? Now I'll show you the same thing on the code block here practically. So I have this program here which I have just shown to you. I will execute it. So it is asking me to enter the values in pounds. So let's say I will enter 25 pounds. It's just an approximate number, and 25 pounds. So it is giving me the value 11.3398. It is very correct answer. So if you multiply 25 with this constant number, which is of course less than 1, so the answer would be less than 25. So we get 11.3398. So the main program body is not performing any kind of mathematics. By mathematics I mean there is no any formula in the main program body. There is only one function, and which is being called to perform the conversion. And once the function has done its job, it is giving us one output value, and which is float in nature, and therefore it is returning us the float here. I hope this idea is very clear to you. Now this statement in function definition basically returns the value to the main program, which is calling the function, right? So let me show you this by example. This statement here, return kilograms, this statement is basically returning you the value of kilograms, which we have found by this formula, right, and which is float in nature. Now this value will be returned to the main program, which is calling this function. So when you call this function, it takes some argument from you and it performs some task and return you some value, and this the value that we obtain will be assigned to the variable which we have mentioned in our main program, right? So in main program we have mentioned that kilograms are basically equal to the pounds to kilogram, and in brackets this is the function name, and the arguments are pounds here. So whatever value we'll get from here will be assigned to this kilograms variable, and this is exactly what's shown here. Now this is the statement in function definition, and it returns us a value which is, suppose it is equal to 74.84, and now this value will be given to the main program body which is calling that function, right, and that will be stored in variable kilograms here, right. At first step in the function definition, it is stored in kilograms. So you might think that this variable and this variable are different by name, however their nature is very similar. This is also in floating nature and this also is in floating nature, which is very okay, right. So whenever any program calls a function, then simply functions that specific function perform its task on the input that is being supplied or provided by the main program body, and then returns us a value, and that value is assigned to the variable which is mentioned in the main program, right. That is how it is happening. Now we can now there are four to five different things that we need to understand. The very first thing is, if there is a function which is not returning any value, then we have to mention void, void. So void simply means null. That means it will not return any kind of value. So we have to have mentioned void there. So if you do not know, or if there is no any output as a number, then you have to mention void there, right. If you know that the function will return as a float or integer or long or character, then you have to have mentioned the nature of the output that is being produced by the function, right. If you will not mention the data type, then the function will think it is by default is an integer, right. So you need to be very explicit that the function will return us this kind of value, right. So the value can be float in nature, can be integer in nature, can be long, can be double, can be character, and if not any kind of type, then it would be a void, right. If you do not mention any of these data types, then definitely the function by default will understand it is integer in nature. So the output of function will be considered as a integer in nature, no matter what your function is returning, but it will be considered as an integer if you will not specify it, right. So this is what you have to be very clear and careful as well. Now we can eliminate unnecessary variables, right. So let me show you one more program which is very similar to this one, but in that program we have eliminated unnecessary variables. Now if you see here, in the main program body, we have only one variable here, which is pounds, right. So in this program we have two variables, pounds and kilograms, which out of which one is input and one is output. But in this program we have only one value as an input, and that is pounds here, and which we are taking from the user, and there is no output mentioned, right. So in the definition, if you see here, it is clearly mentioned return this number multiplied by pounds. So whatever value we take from the user will be multiplied by this number and will automatically be returned to this program. So what we have mentioned on the output side, we have not mentioned kilograms like in this program, but we have mentioned pounds to kilogram. That means this function will return us a value which will be output to us. So we have eliminated two variables. One variable is kilograms from the main body and 1 kilogram itself in the function definition. So we can do this thing to minimize the number of variables being used in the program, to minimize the complexity. But this will not be for the elementary users. So advanced users in computer programming languages try to minimize the variables, right. So when you minimize the variables, so it is very understood that when the function has as input as in a pounds, and it just returns a value, and of course this function will return us a value, and that will float in nature. So directly we have mentioned the function here, we have not mentioned the output variable here. So by this technique we can minimize the number of variables being used in the program, right. So this is the idea and essence of eliminating the unnecessary variables from your program, from the main function and from also the function definition, right. Now let's perform the same thing on the code block here, so that the program which I have shown to you, I'll run this thing here. So if you see, there is no kilograms mentioned, but directly function itself is mentioned, and this function will return us a value which will be pounds multiplied by this number, right. So let me build this thing. and run it. So it is asking me to enter the values in pounds. So again, let me enter 15 pounds. So it is giving me 6.080388, right? So the idea is minimize the variables as possible, but that need to be very clear and that should be understandable, and that is the idea of minimizing the variables. Now let's go with the next topic, which is returning the structure variables. Now in the last video we have seen that we can give structure as an input to a function, right? That means argument to a function. Likewise, we can take structure as an output from a function, which is very possible, right? So we can give structure as an input and we can take structure as an output from the function. There is no any magic. Let me show you one program and then I'll show you the same on the code block as well. So this program is in textbook, starting from the libraries, right? And then we have a structure here, which is a name given as a distance, and it contains two variables. One variable is feet and other is inches. The feet is of integer nature and inches is of float in nature. So this structure has two variables, feet and inches. Now in this program, interestingly, we have two functions. We do not have one function. One function is mentioned with this name, and other function is mentioned with this name, right? So if apparently from declaration it seems like this function will return us a value which will be of distance data type, right? So if you see here, this distance, which is the name of a structure, will be acting like a user defined data type, right? So this distance here is a data type. That means this function will return us a value of this nature, and the other function, which is given this name, will not return us any kind of value, therefore it is void. However, argument to these two functions are distance. So this distance is a data type and this is serving as an argument here to these two functions. So in this program we have used two functions. So the structure here, starting from the libraries, then we have a structure, then we have two functions. One function will perform some kind of mathematics and one function will only display. It will not do any kind of maths. And then this is the main program body here. So we have called the function here, right here we have called the function, and then we have called the function here, we have also called the function here, we have also called the function here, and then right here is the function definition of this function, and at the bottom is the function definition of this function here, right? So in the main program again we have used the same data type here, which is distance, and then there are three variables, d1, d2 and d3. So we will take first distance, and of course distance will be in feet and inches both. So d1 dot feet and d1 dot inches. So these two will be accessing these two variables here. And then again we are taking the second information, which is d2 dot feet and d2 dot inches, right? And now we have called the function, the very first function, this function here, to perform some kind of mathematics. So it is taking two arguments. One argument is d1 and other argument is d2. So d1 is distance this one and d2 is distance this one, right? Now these two arguments are given to this function, and now this function is performing the mathematics here. So if you see, distance data type is given the variable dd1 and distance data type is given variable dd2. So distance 1 and distance 2, and now when you perform addition of these two, we'll get distance third distance, therefore it is mentioned dd3 here. Now the idea is to add inches first, and once you know the net number of inches, then perform the conversion to feet. So step 1, we are summing up the inches from this information and from this information. So inches are added and they are stored in the variable dd3.inches. That means dd3 will be accessing this structure and storing this information into the inches here. So this will be stored in inches here. Okay, and then initially we have mentioned that the feet are equal to 0, and then in the if condition we have mentioned that if the inches are greater than 12, then convert them into the feet. So the feet will increase and inches will decrease, and finally the actual feet will be added up with these feet. That means feet that we have taken from the user, and then again feet from we have taken from the user, we'll add this together and plus that increased value from here. So we'll add this together and finally we'll return dd3. and this function is not performing any kind of task. It is just only displaying the final result, dd.feet and dd.inches. It is only just displaying in a proper format. It is not doing any kind of mathematics. So in the main program, if you see d3 is what? D3 is actually dd3 here. So this dd3 value, which is returned by this function, will be stored or will be assigned to this d3 here. So on the output side, what we will be having is d1 first, and then d2, and finally d3. So d1 will be both d1.feet and inches, and again d2.feet and inches, and then there will be an equals to symbol, and finally d3 as a result. And what is d3? d3 is this thing, and this thing is equal to dd3 here. Right? So there are two functions. One function is performing the mathematics, and one function is only helping us in displaying the results properly. That means feet, and then single quotation mark, and then hyphen, and then inches, and double quotation mark. So this is for only displaying the proper English display of the distance, and this is performing the addition. So it is mentioned addition in English system. So addition in English system of the distances. So these two are the arguments to a function, and these arguments are both distance in nature. So I will not consider them as a variable, but they are basically the data types. So first information is stored right in this distance, which is d1, and d1 is accessed by this distance data type and stored in these two variables, and then again d2, and then these two are basically the argument to the first function, and which will return us the d3. And in the first function we have this mathematics happening here. So we add the inches, and then we see if the inches are greater than 12, we convert them into feet, and then this feet will be added to the actual feet that we have taken from the user, right? And then this function is just only displaying the result properly, right? Now let me show you this thing on the code block here. So I have this program, and let me build it. Okay, and then let me run it. Now it's asking me to enter the feet. So let's say feet are 25, and asking me to perform the inches. So let's say inches are 32 inches, and then again feet. So let's say 45 feet, and it's asking for me the inches. Let's say 34 inches, and then the first information is 25 feet and 32 inches. That is displayed by this function here. When you call this function, it displays this information, and then there is a plus symbol. So if you see on the output side, there is a plus symbol here. Then second information d2 here. When you call this function and give the argument d2, it simply means we want to display this information. And then there is an equals to symbol. So on the output side, if you see, there is an equals to symbol, and then it performs. Then you call this function to do this task, and which is this one, and therefore we have a d3 here. So finally we get the d3 on the output side, 71 feet and 54 inches. So of course when you do this task, you get the same answer, right? So I hope the idea of having two functions in the program is very clear to you. So it's very possible we can use multiple functions, and every single function will be performing one specific task and returning you to the one value. So this function is returning the value of distance in nature, which is actually a name to a structure. However, it will act like a user-defined data type. And other function is not returning you any value, it is just void, so therefore void is mentioned to you. So the function which is returning us a value, as clearly mentioned, return dd3 here. So dd3 is what? Is dd3.feet and this thing, and inches of this thing. So these two informations will be displayed on the output side. Now let's talk about reference arguments. Now reference argument is quite an important topic in functions, and now on we will be talking about different techniques of giving the argument to a function, right? So we have already talked about, but in a very traditional way. Reference argument simply means, when the term reference we use in functions, it simply means we change the variable names, right? We change the variable names for so many reasons, right? Let me give you an example. So in earlier videos we have seen that we can give a constant value as an input to a function, right? And that was known as the arguments by values, right? If you remember, argument by value simply means we took a constant number from the user, a character from a user, and we assigned that specific number or value as an argument to our function, right? And those values were stored in one variable in start, and then the same numbers or values were stored in different variables in main function definition. Like in main program body, we have the variables, suppose character in and number in. So we have done this program earlier, and I'm giving you the example. I'm talking about the traditional way, that the way we give input to a function, and then I'll explain to you the reference by arguments. Now, in traditional way, this is the main program body, and in main program body we have taken two values from the user, and one value is a character which is mentioned in character input here, and other is number input, and these two variables are basically holding these two values. One is this equals to symbol, and one is this 30 here. Now these two, when they become arguments to a function, right, then in the main function definition they are stored, or they are being copied to different variables, right? So in the main function definition, these variables are basically changed, however they contain the same values. So in the main function definition, the variables are character ch and n, meaning number. So these two variables, if you see, are quite different from these variables here. However, they both contain the same value. This character is also equals to, and this n is equals to 30. So these two variables, which are the variables of function definition, contains the same values, which are actually passed by the main program, right? Now this is called passing argument by value. Now let's talk about passing argument by reference. So when you pass argument by reference, you actually change the variable's name, right? And you give access to the original variables. So the function definition can access the original variables and can change the value of them. It is very possible, right? In traditional way, function definition cannot change the values of actual variables, right, of the original variable. But when you do the argument by reference, then the function definition has the authority to change the values of actual variables. That is the difference, right? Let me repeat it. In traditional way, if you adopt the traditional method of giving argument to a function, then the function definition cannot change the values of actual variable. But if you give the argument to a function by reference, then the function definition has the authority to change or to update the values of actual variables, which are basically mentioned in main program body, right? That is the idea. And now if you do this thing, reference by argument, then actually you are not giving access to the variable, but you are giving access to the memory address in which your actual variable is stored. When the function definition reaches to that memory location, it can change the value of that variable, right? Let's suppose in the main program, the value of a variable, say a, has a value of 10. But when this variable become an argument to a function by reference method, then the function definition can update its value by directly accessing its memory location, right? So in simple words, when you give argument by reference, then simply it means you are actually giving authority to the function body to access its memory location, right? Now let me summarize this thing by giving you one appropriate example, right? Now I have one example here. Now in this I'm using a function. Its name is integer fraction. Now before that, let me give you the summary of this program. What this program does is, when you give a number, when you take number from a user, a floating number from a user, it separates the integer part and it separates the fractional part, right? It separates these two. Let's suppose the number is 12.45. So what this program does is it separates the 12, which is integer part, and 0.45, which is the fractional part. So it separates out these two components of a one number, right? And to do this task, the program is adopting or is using one function, and the name of the function is integer fraction. This part is integer and this part is fraction. Now if you see here, this function is three arguments. One argument is float, other argument is also float, and then third argument is also float. And if you see closely, these two arguments are slightly different from this first argument. It is only because this argument is given as in a traditional method, right? But these two arguments is an AND symbol here, and this symbol is called ampersand. Ampersand simply means these two arguments are basically given as argument by the means of reference. So when you give any argument to a function by the means of reference, then you have to have mentioned this ampersand sign. If you do not mention this ampersand sign, then it means these arguments are not the argument by reference, right? So when you put this ampersand sign, it simply means you are giving the function definition the authority to access the memory location of the respective variable which are of these two nature, right? Now interestingly, if you might think that the function declaration should be out of this main program, why this is within the program? And this is what is interesting within this program, and that's what we have to understand. Whenever you give arguments to the function by the means of reference, right, then you have to have put the declaration within the main program. You will not put the function declaration out of the main program. So in general, in traditional method, we give declaration or we mention declaration out of the main program. But whenever you give argument by the means of reference, then you have to keep the function declaration within the main program body, right? Now we have these three variables in our main program body. One variable is number, other variable is integer part, and other variable is fractional part. So that means we take the number from the user, and then we find out the integer part and we find out the fractional part. Now these all three variables are of the float in nature. Now what we have used in our main program is that we have used a do while loop. That means we will be doing this thing continuously until unless our this condition does not satisfy, and the condition is 0.0. That means if you enter 0.0, then your program shuts down, it will close. But if you enter number except 0.0, then this will keep running, right? So this is what do while loop is. So I do not need to explain you the do while loop for sure. Now in the main program body, the program is enter a real number. So the real number means, let's suppose 12.45, 13.65. So we'll enter any number in our program, and this program stores this number into this number variable, and which is float in nature. So this number will be stored in this number here, and then to do this task, and what is the task? Task is to separate the fractional part and the whole number part, right? And to do this task, we have called the function in this integer fraction here. So we have called this function here, and this function is these three arguments. One argument is number, which is in traditional in nature. This integer part, which is like reference, argument by reference, and the fractional part is also argument by reference. Now these two are basically the output. So if you see on Cout, integer part is integer part and fractional part is fractional part. So these two are basically the output statement. Coming to the function definition here. So in function definition we have float n, right? So I mentioned to you the variables in function definition can be different from the variables mentioned in our main program. So the main program, the first variable is number here. So if you see, the argument is number, and the number is float in nature. But in the function definition, if you see, the number is replaced by this n here. So whatever value will take from the user will initially stored in this number variable, and then will be given to this function as an argument, and in function definition the same value is stored in this n here. Now this float ampersand sign means that we have given the function definition access the memory location of this variable. So wherever this variable is stored, we have given the direct location of it. We have given the access of it. So this integer p here is actually integer part here, and this fractional p here is actually the fractional part here. Now we need to understand the function definition. So in function definition, there are some slight ambiguous statement you might see here, but they are very easy to understand. Now we have employed the static cast here. So cast are only used when you want to change the type of data. Now see, the n, which was basically float in nature, is converted into the long. So when you want to convert the data type of any variable, you basically employ the static cast. So there is no need to use any kind of library. By just simply using a static cast, we can convert one data type into another one, right? So now we have introduced one new variable, which is long and temp here, and we will convert this number which is float in nature into long. So we have mentioned the long data type here. It simply means that this float number will be converted into long, and when you convert this number into long, then technically it means that long is of integer nature. So that simply means the fractional part will automatically be expunged, right? So suppose the number is 15.75, then 0.75 will automatically be expunged. Only 15 will be left because this long is integer, and that simply means we will have integer on the output side or long on the output side. So long is nothing but it's integer in nature. So we will have this value here. Now in the second step, we have taken this variable here, which is long, technically it is integer, and we have converted back into float. And we have converted back into float only because we have this integer p variable of float in nature, right? So the number which comes from here, which is integer, will be stored, will be placed in these brackets, and then it will be converted into float because this variable integer p is of float in nature. And now what we want is fractional part. So fractional part is nothing but this actual number which is coming from the user, and then minus this integer part. So when you subtract this actual number from the integer part, then the only part which will be left is fractional part, right? Now in the integer part we have only the integer portion left, and in the fractional part we have only fractional part left. Now from these arguments, if you see here, there is ampersand shown and there is also ampersand shown. It means these two arguments are by the means of reference. It means these two arguments are basically passed by the means of reference here. So when the arguments to a function are passed by the means of reference, then actually we have the access to the memory location, and in the memory location we can update their values, right? So the new values will be this integer part and the fractional part to these respective memory location, right? And this is the only way a function can return multiple values. So if you see in this function, we have the integer part being returned and we have a fractional part being returned. But when you use return statement in the function definition, then only one value can be returned. But because this function is giving you multiple values, then the only way you have is to go by the help of reference arguments. Otherwise you cannot return multiple values from a single function, right? So you would have to use different functions to perform this task, right? Now because we want only single function to give us two outputs, one output is integer part and one output is fractional part, therefore we are using the arguments by the means of reference. So when you use argument by the means of reference, that means these two arguments has basically the access of the memory location of these two variables. So initially these two variables has no values, they were empty, but now they have the integer part and the fractional part. And this number which is taken from the user is actually is given as an argument in traditional way. Therefore there is no ampersand being given, and this program, this function definition, cannot update the value of this n. So this n is number, and this number will remain same throughout the program that is being given by the user. But these two arguments can be updated because these two arguments are being passed by the means of reference arguments, right? So I hope I have made my point, and I'll repeat from the top. So we have the libraries here, and we have a function which is named as integer fraction. It means this function will give us integer part and it will give us the fractional part, and it contains 3 arguments. One argument is float, and other argument is also float, and the last one is also float, but these 2 arguments are by the means of reference. That means we can have access of the respective variable of the memory location. Now we will take the number from the user, and that number will be stored into the number here variable, and then this number is given as an argument, and then these 2 arguments has no value at the moment, but definitely it will have when the function will return us a value. And then finally we have employed this function, and the static cast simply means that we want to convert the number, the data type of one number into another one. So we have a number in float, and then we have converted into long, so that we can have only integer part, and then we have converted integer part back into float only because our variable is of floating nature, and then we have subtracted the actual number from the floating part. Therefore we have only fractional part left, and which is of course in the floating nature. And these 2 variables will directly be stored, I mean the values will directly be stored into the respective memory location, which initially were actually 0, 0. Right? Now let me show you this program on the code block here, right here, and I will run this thing. Let me build it, and it's taking some time. It's done now, and run it now. So let me enter the number. Let's say number is 45.375, right? So it is saying me that integer part is 45 and fractional part is 0.0375, and this will keep going because there's a do while loop. So let me enter another number, 65.77. So it says 65 is the integer part and 0.7697 is the fractional part, right? Now let me enter 0.0. So when you enter 0.0, the program will shut down, because the condition is that the number should not be 0.0. So if the number is 0.0, then the program will definitely shut. So if you see, the fractional part is 0 and the integer part is also 0, but the program will terminate because it meets with the condition, right? Now this is how to basically give argument by the means of reference, and you have to have used this ampersand symbol, otherwise you will not be able to give the argument by the means of reference. What are the benefits? The very first benefit is that the function definition can actually access the actual variables, and when the function definition access the actual variables, that means you can update their values into the memory location, right? And the second benefit is a single function can return you multiple outputs. So if you want that a single function returns you multiple values on the output side, then you have to have give arguments by the means of reference. There is no other way out, right? Now let me explain to you this illustration given in the textbook, and it belongs to the same program which I just explained to you. So in the main program we have this statement here. So we are calling the function which is integer fraction, that is 3 arguments. So one argument is number, second argument is integer part, and third argument is fractional part. Out of these 3 arguments, two of these arguments are being passed by the means of reference, right? And one argument is being passed by the means of traditional way. Now this number argument contains one number that we take from the user, and the same number value is being copied to the function definition, but it is assigned to a different variable, and the name of the variable is n here. Now in function argument, if you see, there are 2 arguments, integer part and fractional part. These 2 arguments initially are empty, they contain no value, but once this task is being performed, this task is being done, the mathematics function definition is being done, then these 2 contains the values, but with these variable name, one is integer part and one is fractional part. So automatically the value that we have obtained by using this mathematics will be stored into their respective memory location, right? And because they are being passed by the means of reference, so we can update the values in the main program body as well, right? So the integer p is integer part and the fraction p is fractional part. Now to give you a better understanding of passing argument by the means of reference, I have one more program to show you and it's a very simple program which can make you understand the idea of passing argument by the means of reference. So if you have not understood the last program, this program can help you in understanding the same concept. Right? Now the idea of this program is that we have a constant numbers, we have a pair of constant numbers, and we want to arrange them. By arranging I mean the smaller number will come first and larger number will come afterwards. Now to do this task we have deployed a function, and the name of the function is order here, right? And this function will not return us any kind of value, therefore the void is mentioned here. Now the idea is the number will be aligned, smaller number will come first and larger number will come afterwards. So therefore we have used this function order here. And then there are two arguments, right? Both arguments are of integer in nature, and these both arguments are being passed by the means of reference. That means initially whatever the values are of the variables can be updated afterwards by the function definition, right? So this ampere sign is indicating that these two arguments are basically being passed by the means of reference, right? So initially one pair of the numbers are integer n1 is 99 and n2 is equal to 11. The second pair of number is integer n3 is equal to 22 and n4 is equal to 88. Now what we want is we want to align these numbers. We want to have smaller number first and larger number afterwards. If you see these two pairs of numbers, in this pair one number is larger and the other number is smaller. So n1 is 99, which should be smaller and then larger. So one pair is already arranged, other pair is not arranged. So this pair, the first pair is not arranged, but second pair is totally arranged, right? Now we have called this function order here, and we have given these two arguments n1 and then n2, and then again call the function n3 and n4. Now in the main function definition, these variables number 1 and number 2 are both of integer nature here. So initially they are n1 and n2, so same n1 here and n2 here. Now to the mathematics here is, if number 1 is greater than number 2, so initially we'll compare these two numbers, so whether the number n1 is greater than n2 or not greater than n2. If the number 1 is greater than n2, then we'll enter into this if body here, otherwise we'll not enter into this if body here. Now because the first pair has n1 greater than n2, therefore we'll enter into this if body here. And initially we have declared one variable of the temporary nature, then the number 1 will be assigned to temporary, and then number 1 will be given the value of number 2, and then number 2 will be given the value of temporary here. So this is just nothing but simply a swiping here. And then finally we have the same values will be returned to number 1 and number 2, and they will be updated to n1 and n2 here. So initially n1 is 99 and n2 is 11, but afterwards n1 will be 11 and n2 will be 99. It simply means this function definition has the authority to update the values of actual variables, and that is simply means the passing arguments by the means of reference. Now I will show you this program on the code block here. Right here I have this program, and I will build it, and then I will run it. Now n1 is 11, n2 is 99, and the second pair is kept same because second pair was already arranged. First pair was not arranged, so it is being arranged now, right? So initially n1 was 99, but on the output side n1 is 11, and n2 was 11, but now n2 is 99. This is being done by this function definition, and when function definition is performed this task, it has automatically updated the actual values. That means we have the access of the actual variables of the program. That's called the argument passing by the means of reference. So I will keep this lecture till this point, and I'll explain the rest of the programs in our upcoming videos. And if you have any question, you may drop me an email or on our WhatsApp group, and try to solve the exercise questions which are given in your textbook of chapter 5, as many as you can solve, right? And if you have any question related to exercise questions, you may ask me, right? Thank you so much, and have a good time. Take care, and Allah Hafiz.